We're going to start by renaming the model. Right-click on Model 1 in the Models tree and choose Rename. Type in Truss Structure and click OK. Next, we're going to create the part. Double-click the Parts item. You see the Create Part window. Let's name our part Truss. Since it's going to be a 2D truss, we're going to set the modeling space to 2D planar. We can set the type to deformable since the truss structure will be deforming under loads. And we'll set the base feature to wire, so we can model the elements of the truss by using wire features. We can set the approximate size to about 10 meters, since this will help with sketching. Then click on Continue. You enter the sketcher mode. We're going to sketch the truss by using the Create Lines Connected tool. You can draw the elements of the truss by moving your mouse around the screen and clicking. Every time you click, you create a node. In this way, you can draw out the entire truss, and when you want to exit out the Create Lines Connected tool, right-click and choose Cancel Procedure. Some of the segments of the sketch span more than one truss element. Therefore, we need to split them up. We can do this using the Split tool. You might find the Split tool hidden behind the Auto Trim tool. To reveal the Split tool, press down on the Auto Trim tool with your mouse. This will reveal the rest of the toolbar. The Split tool is the last tool on the toolbar. At the bottom of the Sketcher window, you can see Abacus prompting you to select the curve that needs to be split. So select the line segment that you want to split, and then select another line segment that intersects with it. The split will be created where these two lines intersect. Repeat the procedure until all the line segments are independent truss elements. We shall now use the Add Constraints tool to specify which of the elements of the truss are of the same length. Click on the Add Constraints tool. You see the Add Constraints window with a number of options. Choose Equal Length. Below the Sketcher window, Abacus prompts you to select the lines for the equal length constraint. You can select multiple line segments by holding down the Shift key and clicking on them. Then click on Done. Repeat the procedure for the other set of equal length segments. We shall now dimension the truss using the Add Dimension tool. Click on each truss segment that you wish to dimension and type in the length in the prompt at the bottom of the Sketcher window. Then hit the Enter key on your keyboard. All the members of our truss have one of two lengths. Since we've already told Abacus which of the segments share the same length, we only need to enter the dimensions twice. Click the red X below the sketcher to exit the dimensioning tool. Then click on Done to exit the sketcher. You can now see the truss displayed in the viewport. Next, we're going to create the material. Double-click on the Materials item. In the Edit Material window, set the name of the material to AISI 1005 Steel. The first material behavior we're going to specify is density. Under the General tab, click on Density. The density of our steel material is 7.872 grams per cubic centimeter. However, we typed in the length of the truss segments in meters, and remember, in Abacus you need to keep your units consistent. Therefore, we're going to set our density to 7,872 kilograms per meter cubed. Next, we're going to set the elastic properties of the material. In the Mechanical tab, choose Elasticity, and from that choose Elastic. The Young's modulus of steel is 200 gigapascals. But once again, remember we need to keep our units consistent. Therefore, we need to write the Young's modulus in pascals. We express this as 200 times 10 to the 9th, or 200 E9. The Poisson's ratio is 0.29. Click OK to close the Edit Material window. You see that our newly created material has been added to the Materials item. Next, we need to create a section. Double-click on the Sections item. In the Create Section window, name the section Truss Section. Set the category to Beam and choose Truss from the type. This tells Abaqus that we're creating a truss structure. Click the Continue button. In the Edit Section window, make sure that the material is set to steel. For the cross-sectional area, type in 3.14 E-4. We get this number because the radius of each truss member is 1 centimeter, or 0.01 meters, and you square that and multiply it by pi to get the area, and that gives you 0.00031416. Then click the OK button. We can now assign the section to the truss. Expand out the parts container and expand out the part called truss. Double-click on Section Assignments. Abaqus prompts you to select the regions to be assigned to section. Using your mouse, select the entire truss structure. You see it light up in red. Then click the Done button. In the Edit Section Assignment window, ensure that the section is set to the section you've just created, which is the truss section. Of course, you don't really have any other options anyway. Then click on OK. I'm going to collapse the parts container so the rest of the tree is visible. Next, we're going to create the assembly. Expand out the assembly container and double-click on Instances. Notice that you are now in the assembly module. In the Create Instance window, set the instance type to Dependent with Mesh on the part. When we later create the mesh, we're going to create it on the part itself, as opposed to creating it on an instance in the assembly. Click the OK button. You see that truss has been added to the Instances container. Now let's define the steps in the simulation. If you expand out the steps container, you notice that Abaqus has already put the initial step in place. Double-click the steps item and you get the Create Step window. We're going to name our step Loading Step. It has by default been inserted after the initial step. We set the procedure type to a static general analysis and click the Continue button. We can type in a description in the Edit Step window and then click the OK button.